Hello and welcome to section 8.1 to 8.3 practice test. We're going to see if we can get through this in a hurry, so let's get started. The first one, if I have x squared equals 25 and I want to square root both sides, the square root of x squared is x, but anytime I square root in an equation, I have to put plus or minus in front of it. So my answer is plus or minus 5. Number two, same process. I'm going to square root both sides. I get x plus 7 because square and square root are opposite operations. On this side, I get plus or minus, and the square root of 9 is 3. And then I'm going to subtract 7 from both sides. Notice that I put the negative 7 in front of the plus or minus. Because they're both integer type numbers, I'm going to simplify to negative 7 plus 3 gives me negative 4, and negative 7 minus 3 gives me negative 10. And those are your two solutions. Number 3, it says to do it by completing the square, so I am going to take 10 divided by 2 and then square it. And so I'm going to say x squared plus 10x plus 25 is equal to negative 9 plus 25. Let me get the rest of this out of the way. Negative 9 plus 25. Notice I have to add it to both sides. Then I can write it as a binomial squared, square root of the first term, square root of the last term, sign in front of the middle term, equals 16. And I'm going to do it like I did the others. By square rooting both sides, I get x plus 5 equals plus or minus 4. And then I'm going to minus the 5. And again, it goes in front of the plus or minus, and I can simplify it to negative 5 plus 4 and negative 5 minus 4. So those are my two solutions. Number 4, again, we're doing it by completing the square. I have to get the 3 to the other side, and I get x squared minus 4x equals 3. And then to complete the square, I have to take half of negative 4, which is my b. Half of negative 4 is negative 2. Negative 2 squared is 4, so I add 4 to this side. I have to add it to the other side. Then I'm going to write it as a binomial squared, square root of the first term, square root of the last term, sign in front of the middle term, equals 7, square root, square root. And notice that this time my square root of this side isn't a perfect squared, so I can't simplify the square root of 7, and so I'm just going to leave it like that. And if I can't have integer there, I'm not going to split it, so that is my answer. Number 5, and this one we're using the quadratic formula, so I'm going to go x equals negative 7 plus or minus the square root 7 squared minus 4 times 1 times c, which is 10, all over 2 times 1. Doing the simplifying thing here, I get 49 minus 40 all over 2. And I know that 49 minus 40 is 9. Square root of 9 is 3. And everything's an integer, so I can split it. Negative 7 plus 3 is negative 4 divided by 2 is negative 2. Negative 7 minus 3 is negative 10. Negative 10 divided by 2 is negative 5. Those are your two solutions. On number 6, we're going to solve it by any method. So I'm going to subtract 15 from both sides. And I get 3x squared equals negative 15. Divide by 3, divide by 3. I get x squared equals negative 5. Square root, square root. And I know I'm going to have a plus or minus in front of this. The negative 1 comes out as an I because the square root of negative 1 is I. And I get plus or minus I root 5. Number 7, again, they tell us to use any method, so I'm going to do it by solving for x. And I get x squared equals 12, square root, x equals plus or minus the square root of 12. And we want to simplify that to 4 times 3 is 12, so 4 comes out as 2 root 3. Number 8. Here I'm going to do it by any method again, it says, but I want to add 2x to both sides, and I want to get one side to equal 0, and I think I'm going to use the quadratic formula for this one. So I'm going to start out x equals negative 2 plus or minus the square root of 2 squared minus 4 times 5 times negative 2, don't forget to bring the negative with, all over 2 times 5. Let's do some simplifying here. I get 4 plus, because negative times negative is positive, 40 over 10, which simplifies to negative 2 plus or minus root 44 over 10. And if I simplify, that's 4 times 11. The 4 comes out as a 2, so I go negative 2 plus or minus 2 root of 11 all over 10. All my numbers here are divisible by 2, so let's finish by going negative 1 plus or minus root 11 all over 5. Just dividing each of those by 2. The discriminant is 7. If the discriminant is 7, remember the discriminant is the b squared minus 4ac. We don't put it under the square root when we call it a discriminant. And if that's positive, which is greater than 0, then we get 2 real solutions. On this one, when it's equal to 0, if b squared minus 4ac is equal to 0, then we get 1 real solution. Number 11, it actually asks us to calculate the discriminant. So I'm going to write b squared minus 4ac, and then I'm going to find out what that is. I get 3 squared minus 4 times 2 times negative 6, which gives me 9. Negative times negative is positive 48, which gives me 57. Number 12. It says to solve, and we want to check our answers because I'm going to be squaring both sides to solve it. 3x quantity squared gives me 9x squared equals 8x plus 1. We want to move it to one side, so I get a 0 on this side. So I get a negative 8x and a minus 1. We have a couple options. I'm going to use the quadratic formula. And so I'm going to go x equals negative negative 8, which gives me positive 8, plus or minus the square root, negative 8 squared minus 4 times 9 times negative 1, all over 2 times 9. Doing a little simplifying on that, I get 8 plus or minus the square root of 64 plus 36 all over 18. I know 64 plus 36 is 100, and the square root of 100 is 10. And so I get 8 plus 10 is 18. 18 divided by 18 gives me 1. 8 minus 10 gives me negative 2 over 18 simplified gives me negative 1/9. Number 13, same thing here, except for when I square this side, I get a binomial squared. When you do a binomial squared, it's the same as multiplying it by itself. So I'm going to take it times itself. And this side, square and square root, go away. And on this side, I'm foiling. I get n squared plus 2n. Inside, inside, last, last. And I want one side to say 0, so I'm going to subtract the 9n. And I get 0 equals n squared minus 5n plus 4. That's factorable, so I'm going to use that method, which gives me n minus 1 and n minus 4. And so I get my two solutions are 1 and 4. Now, when I do that, I need to check to make sure that both of those answers work. And so when I plug it in here, back into the original, if I go square root of 9 times 1 equals 1 plus 2, gives me 3 equals 3. That's a good answer. If I do it for 4, I get square root of 9 times 4 is equal to 4 plus 2, and square root of 36 is 6, so that one works also. They both worked. On the last one here, we're asked to find what x is, and so we're going to do Pythagorean theorem, and we have x squared plus x plus 8 squared equals 36 squared, using the Pythagorean theorem. If I multiply this out, I get x squared plus 8x plus 8x plus 64 equals 1296. Simplifying, I get 2x squared plus 16x. Moving this to the other side, I get negative 1232, not 3, 1232 equals 0. And I want to factor out 2 out of everything because the numbers are just too big for me to do. So I'm going to do that, and I get minus 616 equals 0. Then I'm going to plug it into my quadratic formula. And I'm going to leave this 2 out because that doesn't change the values. So I get x equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 616 all over 2 times 1. And simplifying that down, I get negative 8 plus or minus the square root of 28 all over 2. And I want the positive root. I only want the positive root because x is a length. And so I put this into my calculator, subtracted 8, divide by 2, and I get 21.1. Good luck!